Hey everybody, this is Chris Dingman, the Math and Science Explainer-rater. This video is an introduction to quadratic functions and parabolas. And you can watch it on its own, but it's also the first video in my series on quadratic functions and parabolas. So if you're watching that series, start with this video. All right, so we're talking about quadratic functions and parabolas, and they're kind of the same thing. They're like a different way of saying the same thing, and we'll get into that later. Let's talk about quadratic functions. Now, first I want to focus on that word function, because lots of times students lose track of what a function is, just in general. So there's different kinds of functions. There's what we call linear functions, quadratic functions, polynomials, etc., exponential. And they're basically, functions are like equations where you have an input and an output. So you may remember linear functions, they're in this form. For example, you could have y equals 3x minus 7. So notice there's an x and a y here. X is like a little place where you can put in any number you want. Like I could put in a 1 there, or I could put in a negative 19. And once you put a number in, like let's say 1, make things nice and easy. I like easy. Y equals 3 minus 7, y equals negative 4. So notice I input a number, and I just chose randomly 1. Well, not that random. I wanted it to be easy. And then we outputted a negative 4. That's how functions work. You input a number, and then the function spits out another number. Okay, now I said quadratic functions are kind of the same thing as parabolas. What did I mean by that? Well, here's what I mean by that. Let's look at a quadratic function. And to be specific, let's look at the simplest quadratic function there is. Y equals x squared. That's as simple as quadratic functions get. See, quadratic functions have to have an x squared in it. They have y equals something. They have y equals something, and there's an x squared in it. And they can't have any power higher than it squared. So it couldn't be like, you couldn't have y equals x cubed. That's no longer a quadratic function. But you could have x's to a lower power than that. I could add something in front of that x squared, and then I could add an x term, like let's say minus 8x. That would be x to the 1, right? But we don't typically show the 1. And then I could be like plus anything, 17x to the 0. But x to the 0 is just 1, so that just goes away. And that's a quadratic because all the powers of x are 2 or less. All right, so quadratic functions, that's what they are. Now I want to talk about the connection between a quadratic function and a parabola, as promised. So a parabola is a particular shape on a graph. I'll just draw a few parabolas for you. Here's a parabola facing up, and it has what's called a vertex right there. That's the turnaround point. Don't worry about that too much now. Here's another parabola. It's wider and it faces down. Its vertex is over here. Let's do one more parabola. It's really narrow and it's up here. Okay, so those are just examples of parabolas. Now, the thing that lots of students lose track of is the connection between a function and its graph, okay? So in this case, that's the connection between a quadratic function and a parabola graph. What could be the possible connection between y equals x squared and some shape over here? What? How do you go from variables and numbers to like a line, a smooth line? How does that happen? Glad you asked. And if you didn't ask, you can always stop the video and go have a sandwich. All right, so here's the connection. You want to make a table of values. All right, let's move this function over. And a table of values is just writing some inputs and seeing what you get for some outputs. So I'm going to pick a number for x. I'm going to pick -3 for x. I could have picked -113.897. You can input whatever you want into these functions, but certain numbers are going to be a little more convenient, that's all. Okay, so we input a -3, what happens? Y equals not x squared, but -3 squared. Okay, which means y equals -3 times -3 is +9. Now, a little aside, when you plug numbers into an equation, it's a really good habit to put parentheses around them. Boom, boom. All right, so I just found out that when I input a -3 for x, I output a 9 for y. So I write the output there. Okay, let's keep going with some other numbers. -2. Didn't see that coming, did you? All right, y equals -2 squared. -2 times -2 is +4. So I'm outputting a +4. Okay, let's input a -1. Y equals -1 squared. -1 squared is 1. So I output a 1. All right, don't go away. I'm only going to do this 2 more times. I'm going to input a 0 for x. Y equals 0 squared. 0 squared is 0. So I output a 0 for y. When you input a +1, you get a +1. Input a +2, you get a 4. And you input a +3, you get a 9. All right. Now, so all I did was stick in some numbers for x and get some outputs for y. Now, here's the key thing that you may already remember this, but it's a really good reminder, and lots of people forget this. Here's the key thing. Over here in the visual representation, the x and y axis are not named those randomly. The x-axis is the input values, and the y-axis is the output values. So I can write all these inputs and outputs as points. Okay, so inputting a -3 and outputting a 9 means I have points on my graph of -3, 9. So over here I go 1, 2, 3, that's -3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a point on my graph. That point is -3, 9. Then I just keep doing that. -2, 4 is a point on this graph. 1, 2, 3, 4. That's a point. -1, 1 is a point. That's about right there. I'm not going to label that one. 0, 0 is a point. That's right there. We call that the origin. We have to have a fancy name just to impress people. 1, 1 is a point on the graph. Right? That's what I just did there. 2, 4 is a point on the graph. That's going to be right there. I'll label that one. And then finally 3, 9 is a point on the graph. That's going to be right about there. Now, if you keep doing this, if I wanted to bore the pants off you and just keep plugging in numbers and getting inputs and outputs, you'd get a bunch of dots. You know, some would be decimals and stuff. You would get a bunch of dots, and they would all follow a pattern. And as you can see, that pattern is called, or looks like, a parabola, what I was calling a parabola. Right? So the line of a graph is actually an infinite number of points. Right? If I just kept drawing points, as many points as I could, they'd all smear together into a line. So it's easy to lose track of that when you look at these smooth graphs, and then you look at these functions or a table of values. It's easy to lose track of the fact that those smooth lines are really an infinite set of coordinates. Okay? So remember that. That's the connection between a function and a graph, and in this case, between a quadratic function and a graph called a parabola. Okay, so we're going to move on now and get into some more details about quadratic functions and parabolas, and we're going to get some more complicated quadratic functions, and that's going to affect how the parabola looks. Okay, so this is just one parabola. It happens to be a graph of the simplest quadratic function, y equals x squared, and other quadratic functions. I'll just give you a quick preview. There's another quadratic equation that's going to make a different parabola. That parabola might look like this. I don't really know what it's going to look like, but that's the kind of thing we're going to talk about. How do you take a function and figure out what the parabola is going to look like? So that's the heart of this lesson. Stick around just for a little bit here, and I just want to do a quick kind of reminder that, circling back to what I said at the beginning, there are other kinds of functions, and I mentioned linear functions as one kind. Linear functions, as you may remember, and as I mentioned, are things like 3x minus 7. And if I make a table of values for a linear function, and I start inputting x's and outputting y's, inputting, and I start graphing those, making dots, they follow, guess what? Guess why they're called linear functions? They make lines, as you probably or may remember. So this is just to reinforce and remind you that different types of functions, or we could call them equations, translate over in the visual world of graphs to different shapes of graphs. And so in algebra, you start to study some of these different types and shapes. And of course, they all have variations. Like I said, parabolas can be wide or narrow. Lines can slope up, or they can slope down, or they can be up high, down low, etc. All right, so that wraps up this video on Introduction to Quadratic Functions and Parabolas. If you're watching this video in my series on quadratic functions and parabolas, the next video is the vertex form of quadratics. See you there.